to request you all to rise from your seats so that we shall observe 2 minutes of silence to mourn the passing of our Assam's beloved, Zubeen Garg. Please be seated. Thank you. Distinguished guests, respective professors, esteemed students, and dear friends, it is my profound privilege to welcome you all to this special gathering where we have come to celebrate Assam's one of brightest luminaries, Dr. Hiranya Chandra Bhuyan, and also relive the trailblazing spirit of popular science talks that he delivered for the Assam Science Society. Today's event is designed to rekindle the passion for knowledge, curiosity, inquiry that Dr. Bhuyan so deeply cherished. As we immerse ourselves in this atmosphere of enlightenment, let us reflect on the enduring legacy of a genius who taught us science is just not about discovery. It's about service to society and nurturing future generations. With this, it is my honor and privilege to introduce you to our first distinguished speaker, Dr. Dhruba Saikia, a luminary in the field of astrophysics and a revered educator. Dr. Saikia has dedicated over 40 years in the pursuit of scientific excellence at the National Center of Radio Astrophysics for the Tata Institute of Fundamental Research. He served as the founding Vice-Chancellor of Cotton University, Guwahati, and held academic and research positions at globally renowned institutes from Jodrell Bank Observatory, University of Manchester, to the National Radio Astronomy Observatory in the United States, and many more. An accomplished researcher with over 180 publications in esteemed journals, and a fellow of the National Academy of Science, India. Dr. Saikia is not just a scientist, but a passionate birder and lifelong educator. In today's talk, Dr. Saikia will take us on an extraordinary journey. One question that has been thought by mankind for long: are we alone in this universe? He will illuminate the vast mysteries of space and challenge us to think beyond our terrestrial boundaries. With that, I would like to welcome Dr. Dhruba Saikia on the dais. Please, sir.
A very good morning to all of you. It's a real honor and a privilege for me to have this opportunity to give a talk and discuss with you all to celebrate the life and contributions of one of Assam's very illustrious sons, Dr. Hiranya Bhuyan, who was extremely dear to many of us, perhaps in different ways, a person who contributed immensely in both education and research and contributions to society. But he did it very quietly, without much song and dance, and it is up to us to appreciate the contributions that he made long after he has gone. And I must thank the missionary zeal of Dr. Zubeen Bhuyan and his entire team for making this possible, not only bringing out the book, but bringing us all together this morning. I chose a theme for today's discussion or presentation with you all, a theme which is sort of central to many of us in mankind's quest of trying to understand our relationship to the universe, how we may have evolved, and whether we are alone in the universe. I realize that many of us are not from the science background, so I'll try to keep it as simple as possible. But I'll also try to use slightly technical words for students of science or teachers of science who may also be present over here today. But I'll try to get it across so that there is something for everybody over here. So first, what I will do is I will try to give you some idea of the immensity of the universe, just to figure out that, can we be alone at all in such a large universe? And before I go further, I should also mention that I'll stick to my time. I think I have to finish by 12, right? 12, I think, yeah. Okay, so I'll keep time on that. But feel free to ask any questions, particularly the students who are present today. make it as interactive as possible. Normally what I do when I speak with students is that if they don't ask questions, I keep asking them questions. But today I'll probably not do that because it's a very mixed audience over here. So let's start off, just to give you an idea of the immensity of the universe. Okay. Now, first let's just look at our galaxy. Our galaxy is one of, as we'll see in a short while, of trillions of galaxies in the universe. All right. And we are not in any very special location of the universe, of our galaxy itself. What it gives over here at the bottom is a kind of scale from a song composed by Monty Python, the British spastic sort of humor group, but the numbers are approximately correct, okay? We are inside the galaxy, so it's very difficult to actually find out how it is. When you can look at something from outside, then it is easy to figure out what it looks like. But when you're inside it, and the galaxy is full of gas and dust, then it is much more difficult. But that is a very interesting kind of story in itself, which we'll not spend much time today because of the shortage of time. But what you can see over here is that we are over here. The sun is over here. We are in a very sort of ordinary position in the galaxy. We are about 28,000 light years away. Just to sort of recap, a light year is a distance that light would travel in a year. Light travels from the moon to us in about 1.2 seconds or so, from the sun in about 8 minutes, but from the center of our galaxy, it takes about 28,000 years. So that is the kind of scale that we're talking about. And from the end to end of this galaxy, it's roughly about 100,000 light years. That means light would take about 100,000 years to go from one end of the galaxy to another. So you can see the difficulties in actually trying to look at things very far away, particularly if there are intelligent civilizations trying to communicate, that it'll take a long time to reach us. It has a disk. I'll show you another picture in a short while. It has a bulge. There is a bar over here in the center. There are stars in the disk of the galaxy, and there is a halo of stars as well. And this whole galaxy is embedded in what is called a dark matter halo. What you and I are made of in physics are referred to as baryons, which are protons, neutrons for physicists or science or people who have had a science background. But a lot of energy, a lot of matter in the universe is something which does not emit any radiation. We can see each one of us today because light gets reflected, or we can see things because light is being emitted. But dark matter is one where there is no emission of radiation. It only exerts its influence due to the force of gravity, all right? And bulk of the matter is actually dark matter. More than 80% of the mass of our galaxy is dark. It doesn't interact. So that is a picture of our galaxy if you look at it sideways. But if you look at it edgeways, if you could go out and look at it from top, what you would see is this bar over here. You would see various arms around over here. And this galaxy looks like a spiral. And these galaxies with such arms are referred to as spiral galaxies. Okay? Galaxies come in a variety of shapes and sizes, but we'll not digress too much into it. But spiral galaxies are an important component of it, and our galaxy itself is a spiral galaxy with a little bar over there. The number of stars have been estimated to be about between 100 to 400 billion stars in our galaxy. And estimates vary a little bit because of the uncertainties, but this is the rough number by actually counting up stars in specific regions of our galaxy and extrapolating. The sun is a very ordinary star. There's nothing special about our sun. So when there is nothing special about our sun itself, it is natural to ask that why should life just exist in one planetary system with a very nondescript star amongst billions of stars which exist in our galaxy. It's also interesting to ask oneself that when we look at the night sky, we see the stars. You can ask oneself the question that what is the volume or fraction of volume of a galaxy that is occupied by stars? If you hazard a guess when I ask students, they'll say 1%, 2%, 3%. But when you actually do the sums, you can do a very simple sum by calculating the volume of the sun. You know the radius, 4/3 pi r cubed, and you can also know the distance to the nearest star, which is the Alpha Centauri group, which is about 4 light years away, or 4 parsecs, which is 12 light years away. Now, what you can do is that you can calculate the ratio of the volumes. and you'll find that it's extremely tiny. It's smaller than 1 part in 10 to the power of 20. What does it mean? That means today if you had a grain of sand representing a star or sun in this Netflix auditorium, the next star would be somewhere in Nagaon or something, another grain of sand. So the bulk of the space in our galaxy is not occupied by stars. What is it occupied by then? Is it empty? The answer is no, it's not empty. It's full of gas and dust. Gas and dust consisting of all the metals which make us up. For example, doctors will tell you that if your potassium and sodium levels are not right, carbon is the basis of life, oxygen, what we breathe in, they're all made. Where do these elements come from? These elements, as we understand it today, come from the interiors of massive stars where they get synthesized due to the nuclear reactions that are taking place. So as new generations of stars are forming in our galaxy, it is forming from the medium which lies between the stars. Okay? We'll take a little bit of a look at the formation of stars and planetary systems, because that is central to the question of whether we are alone. We have to understand how stars form. We have to understand how planetary systems form, like our own planetary system in our galaxy, in our solar system, to understand how stars may have formed. And for stars to form from clouds of gas, they have to collapse, because stars have to be compact, temperatures have to be very high in the central regions for nuclear reactions to take place, just as in our sun. And for that to happen, clouds will have to collapse. And for clouds to collapse, if it is very high temperature, it is very difficult for gravity to make it collapse. So temperatures have to be low. So you'll find that in interstellar medium, you will also get components of gas which are extremely cold, 10 degrees, 20 degrees Kelvin, which is about minus 260 degrees centigrade or so. So it will be extremely cold regions. In these regions, which are the regions where stars form. Now, let's look at one particular slide, a small video to show you the clouds of gas where, let me see if this plays on its own. It's playing. This is from the James Webb Space Telescope. It's very short.
The pillars of creation lie 6,500 light years away. This area is brimming with gas and dust, essential ingredients for star formation. A new near-infrared image from the Webb Space Telescope shows the scene in high definition. Glowing, bright red wavy lines appear at the edges of some pillars, revealing where stars are ejecting material as they form. The bright red orbs are newly formed stars that have burst into view. Distant galaxies typically make appearances in Webb's images, but not this one. A translucent layer of gas and dust is drawn like a curtain, allowing the stars to take center stage. Webb's near-infrared image of the pillars of creation will help researchers update their models of star formation. Over time, we'll learn how stars form and burst out of these dusty clouds over millions of years.
So this is just one particular region of the sky referred to as the pillars of creation because of those pillars which you see. And these are cold regions. They're not very hot regions like the surface of the sun. You get components of the medium between the stars which can be very hot. And these are like the stellar nurseries where gas collapses to form stars and planets from which life can originate. And to reinforce the point that what we are made up of is essentially stardust, because the elements that we are made of, as I tried to highlight a short while earlier, is something which can only be synthesized in the interiors of stars. Today we have a fair idea of how the universe evolved, although there are challenges, and the universe originated from a very hot, what they refer to as a Big Bang, but a very hot early phase of the universe, where temperatures were extremely high, and then as the universe kept expanding, it cooled, and it is only hydrogen and helium, the two of the lightest elements, and hydrogen being the most abundant element in the universe, which could have been synthesized as we understand the evolution of the universe today. So all the heavy elements beyond hydrogen and helium would have to be synthesized in the interiors of stars. So the question as to the origin of life being at all there is intimately related to the fact that stars are born and stars evolve. Now, what is the kind of number of stars and the number of galaxies that we are talking about today? This is an image of our galaxy taken by an amateur photographer who put together hundreds of thousands of photographs together, Axel Millinger. This is the plane of our galaxy. This is an actual photograph. And what you see are these dark patches over here are because of the dust and gas, which I told you earlier, where there is dense gas and dust. It tends to cut off the light from the stars behind it. And so you see these dark patches. If you were to see the same galaxy at longer wavelengths, for example, in the infrared region. For example, when the sun sets, you can see the long wavelength red waves coming through, and that is why the sun appears red. Similarly, if you took a picture of our galaxy in the infrared, these dark patches would disappear. But this is what our galaxy would look like, and this is our nearest neighbor large galaxy called the Andromeda Galaxy, the Andromeda Nebula, which is about 2.5 million light years away. It's slightly larger than our galaxy, and it contains about 1 trillion stars compared to 100 million to 400 billion, 100 billion to 400 billion for our own galaxy. Now, having had an idea of how many stars there are in our galaxy, let's also try to get an idea of how many galaxies there may be in the universe. So what I've shown over here today are two very deep images, one taken with the Hubble Space Telescope over here, and the next one has been taken by the James Webb Space Telescope, which is the largest telescope in space today, with a diameter of the lenses, multiple mirrors are there, about over 6 meters in diameter. And what you can see over here is that this is a very tiny region. This is just 2 arc minutes by 2 arc minutes in the sky. What it means is that if you took a small 1 millimeter square, held it at an arm's length, that would be about a couple of arc minutes or so. So you can see it's a very, very tiny region of the sky that has been imaged to see how far you can go, how deep you can go, what are the faintest objects in the universe that these telescopes can pick up. And this is millions and millions of times fainter than what the eye can pick up when you look at the night sky, literally millions of times. And this tiny region of the sky, has more than 10,000 galaxies of different shapes, different colors, different populations of stars. Each fuzz that you see over there is a galaxy. When you count them, there are over 10,000 in the Hubble Space Telescope image, and it is over 15,000 in this image. And this little red dot which you see over here, little red patch, that is the most distant galaxy that we know of today, which is actually, with the light is taken to reach us, it started off about 13.4 billion years ago. That means it is almost close to when the universe first started forming galaxies, and that was one of the motivations of the James Webb Space Telescope. So we can see that in each galaxy, there are trillions of galaxies, at least 2 trillion galaxies in the universe, and also each galaxy has billions of stars. So if you multiply these two, you can see the huge staggering number that we have in terms of the number of stars in the universe. And our star, the sun, as I mentioned earlier, there's nothing special about it. It's a very ordinary star in our own galaxy. So then it begs the question that when there are trillions of stars, what is the probability that life just exists in just one little tiny speck? It's highly improbable, okay? And so life must exist somewhere, and life must exist in other planetary systems, and that is what the whole quest has been. The question has been posed many hundreds of years ago since antiquity, but we have been able to address it with some degree of satisfaction in more recent times. So that is what we will try to address today in the next 50 minutes or so. And if you have any questions, please feel to ask me. So if you have any questions, just put your hand up and just ask, okay? So it's always more lively to have a discussion than to have a monologue. So feel free to ask, okay? Now, having introduced to the kind of scale of the universe, the kinds of number of stars and the number of galaxies on which planetary systems must exist or should exist, let's look at the question of life itself, okay? I have, biologist friends over here whom who I'm sure will help me when I hear. There's Hiranya Chandra from Cotton over here. And so let us try and understand for a little bit, when we're searching for life, what do we mean? What is life itself? Okay, this is the question which has been asked by experts many times, and a debate probably still continues. Okay, now there was a conference of leading scientists. This was where Koshland, who was the editor-in-chief of Science, one of the leading journals, he was part of this committee, and he actually recounted an anecdotal account where leading scientists sat down together to ask, let us define life. What is life? And they came up with various suggestions, and each one they put a hole and it came down. And one person said, well, the ability to reproduce, that is the essential of life. Okay, if you can reproduce. Then somebody in the audience said, well, then one rabbit is not life because one rabbit cannot reproduce. You need a male and a female. So you can see the intricacy, not only science, but even philosophy, logic, everything comes into play to ask oneself, what is science really? For example, if you take crystals, let's take sodium chloride crystals, you can powder them, you can seed crystals, they will grow. And as Dr. Hiranya Bhuyan said, he worked on imperfections in crystals. Those crystals will also have imperfections. They will grow. And is that life? The answer is not. And we'll come to that in a little while. Okay? Now, whatever way we define life, it has to be universal and motivated to some extent by our own theoretical or experimental understanding. In the labs, what we do, what we see, what we experiment. And one of the beautiful things about science is that it is universal. For example, Newton made a huge leap when he saw an apple fall from a tree, as the anecdote goes, and he generalized gravity to the whole universe. It was a huge leap of faith. But today we know from all the detailed calculations that have been done that if I take an element in the earth today, look at what its properties are, I can see the same properties from the most distant parts of the galaxies, using the same physics that we have developed over here. That is truly amazing. So the chemistry and physics that we understand it from science today is indeed universal. It is not just confined to the Earth or this planetary system. So the way we try to understand life also has to be some universal, but there will be biases and there will be challenges. And that is what we'll briefly talk before we get into. There was a committee assembled by NASA in 1994, and they actually deliberated quite a bit. And there may be probably other better definitions which you can tell us about. But what is said, it's a self-sustaining chemical system capable of Darwinian evolution. Okay? Self-sustaining chemical system. And the chemistry of life is actually an extremely exciting field. There's some work being done in India as well. Starting off with IIT Pune has a good group over there which is working on it. And the example which I mentioned, that crystals, you can powder it down, you can make crystals grow, you can make replicate. They will have defects in the crystals as well. But it is not Darwinian evolution. It's not genes which carry the information. So that is not life. So the concept of Darwinian evolution that we understand today is something which is built into this definition of life in this committee which was suggested. And this has been used widely in the literature, although today because of genetic sort of, manipulations, etc., that people are also talking about supra-Darwinian evolution, and one will have to see how that evolves. Maybe, in 100,000 years from now, we'll have supra-Darwinian evolution if we continue in the same way. But the way things are looking at this earth, the way we are destroying it, I don't know how long we'll survive. But as I say this, that when we look for life elsewhere, that we're normally what you're familiar with, we'll also have to look at a much wider spectrum. Okay? Actually, those of you who are taking pictures, of course, you're welcome to take pictures, but I'll be happy to share a PDF file. My email address was in the first slide, and I will be happy to send you a PDF file of it if you want to have a look at it in more detail. Because usually I put the credits and the references in the bottom so that you can have a more leisurely look at what is where I got the material from. So normally we don't think of, we only think of life depending on water, life depending on oxygen, a normal temperature where water is in liquid form. But what we see even on the earth, that there are organisms which live in extreme environments. Okay? And these are called extremophiles, and they thrive in extreme environments. Some actually thrive in these extreme environments. Some tolerate it and are able to survive. But some actually flourish in these extreme environments. And that is something which we have to have to sort of be conscious of or take cognizance of when we are looking for life elsewhere. So we know that, for example, at more than 100 degrees centigrade, 122, minus 20 degrees. So I will not get into a long list, but I just wanted to mention about this particular microorganism called a tardigrade, because it survives temperatures which are not absolute zero. It's a bit of an exaggeration when I say close to absolute zero, but that's the lowest temperature which you get when everything sort of freezes. Motion of electrons freeze. But even at those very close to it, not very far, to about 150 degrees centigrade, extreme dehydration, vacuum, pressures of 6,000 times the pressure of our atmosphere, high energy radiation. Somebody even actually froze them, fired it with a gun for a few meters, they survived. So these are the kinds of extreme organisms which we are familiar with. I mean, of course, we are all familiar with the tetanus, for example, which is an anaerobic bacteria, which doesn't require oxygen. Okay, and when the Earth first evolved, there was no oxygen over there. That came later. And actually, these extremophiles also play a very important role, because some of these, for example, I think this for biologists, the PCR, the enzyme catalyst comes from one of these extremophiles, which were first recognized in the Yellowstone National Park. So I think when we're looking for life, one is to be aware of the definition of life, and the other is to be conscious of the fact that life can exist not just in ways that we are familiar with from everyday situations, but in extreme situations as well. Of course, detecting it is always a challenge, and that is something which we will look at it in a little while, the progress which has been made. Now, central to the detection of life is to understand how actually life originated on the Earth, how planets may have originated, how a stellar system, we call our system the solar system, but similar systems of planetary systems associated with other stars may have originated. And that is something which there has been a lot of progress in recent times due to the development largely of very powerful telescopes, and also because of an improved theoretical understanding of how these systems may have evolved. What I've shown over here are images of planetary systems under formation. Now, what happens? For example, I mentioned a little while earlier that stars form by the collapse of clouds. Now, what happens when a cloud collapses is that the clouds are also spinning. And because it is spinning, you'll get forces which come into play. For example, just as you run your washing machine to dry up your clothes, there'll be forces which will push it outwards, called the centrifugal force. Similarly, when a gas tries to collapse, these centrifugal forces will come into play in an axis which is perpendicular to the direction which it is rotating. In a direction along which it is rotating is going to collapse because there is no force to support the force of gravity. So what happens is that you get a disk kind of structure. That is why you find that all our planets, for example, are roughly in a plane. All right? Are roughly in a plane. And this is what you see when the disks are forming, that initially there would be a lot of gas which will form a disk. Then as a disk forms, there would be inhomogeneities which will pick up. Nature is never very homogeneous. So where there is a slightly larger amount of matter or mass, it will attract more mass. And slowly planets will start building up from these smaller blocks, and the disk itself will disappear. And what you will get is a planetary system around a star, just as in our own solar system. So these are images which have been taken in the optical region of the electromagnetic spectrum with the Hubble Space Telescope. This is an image which is taken at millimeter wavelengths by the Atacama Large Millimeter Array, and these are similar images taken with ALMA, as we call it over here. So now, this is something which is seen widely in stellar systems. So what I'm trying to illustrate over here is not only there are trillions and trillions of stars, but the way stars themselves form, there has to be planetary systems associated with it. How we detect it is something we'll come to later, and central to the question of whether we are alone in the universe is the fact that planetary systems exist. It's a routine thing in stars. Okay? That again is a question which was asked from ancient times, but answers to that is something which we have got in more recent times. And all that has to do with, a lot of it is technology as well. This I will skip probably, it's a little technical, so I'll just skip this. All right. Now, when the Earth first formed, we'll look at this in a bit more detail later, that initially it was really, a hot gas before things condensed, the disk was very hot, and the Earth itself was bombarded by comets, asteroids, all kinds of things which possibly created water and also helped in creating life over here. Now, just to put the Earth numbers in place, the age of the Earth as we know it today is about 4.5 billion years old. Our sun, that will be similar to the age of the sun, and the sun is expected to live about 10 billion years or so. The age of our galaxy is about 13.5 billion years old, and the age of the universe roughly is about 13.8 billion years. I'll not get into details of how we estimate that because of shortage of time, but just to mention about our galaxy itself, there are ways of trying to estimate the ages of stars in our galaxy. Our galaxy can be as old as only the oldest stars that are there in our galaxy. The oldest stars that we know about are of this order of 13.5 billion years, and those are the rough time scales to bear in mind. Why is it important to bear this in mind? We'll come to it in more detail later again. It's because if you look at the evolution of the planetary system, our planetary system, as we can see, the Earth is 4.5 billion years old. When we look at when life originated on the Earth, it's a few billion years old. But when intelligent life, or what we're able to do today, is something extremely recent in the geological history of the Earth itself. So if you convert it into a 24-hour clock, we are just about 1 minute to 12 o'clock. All right? So you can see that you have required 4.5 billion years to have life which can actually question the origin of the universe. To have life which can ask the question, how did life originate? To the question, are we alone in the universe? It required so much of time. So if you had a star which actually lived for millions of years, it would never be able, the probability of trying to evolve so rapidly would have been almost impossible. All right? Now, the next question to ask oneself is, how did life originate? What are the ideas? So life, it is generally believed, although we have made a lot of progress, but still a lot remains to be done, is that life really originated from inorganic reactions to form organic molecules and more complex systems from which strands of RNA, DNA, or amino acids initially, proteins, etc. formed. So it has an inorganic kind of origin which really later led to the formation of life. And some of the early ideas, some of the breakthroughs that I mentioned over here are the synthesis of urea. Because at that time when urea, which is an organic substance consisting of carbon and hydrogen bonds, that was synthesized, the general belief was that only living things could generate inorganic material. And that was a big step when Frederick Wöhler, the chemist, actually synthesized urea. Then, of course, Oparin, the Russian sort of chemist, and John Haldane gave his theories in 1924 and 1929, I think, to say that inorganic substances were synthesized in the kind of environments which existed in the early evolution of our Earth to be able to synthesize the molecules which later combined to form life, the monomers and the polymers. And one of the breakthrough experiments was done by the graduate student Stanley Miller, who was working with Harold Urey. What they did was they created an atmosphere over here which was pre-oxygen in the early stages of the evolution of our Earth, heated sort of seawater, had a spark over here to induce reactions, because to synthesize these large molecules you need energy, which they tried to sort of put in place with an electric spark over here. And they were able to synthesize molecules, which are the organic molecules, which would be the first stages, the initial stages of creating life. So the fact that these biomolecules can occur due to the combination of other elements was something which was experimentally demonstrated. And then we have actually made a lot of progress since then, although I don't think we have actually made a cell, but we have made small genomes which we have inserted into cells, tried to replicate them. But the origins of life originated about initial period when the Earth was about 0.7 billion years old, heavily bombarded, and through a complex chain of evolutionary events. There are also ideas that some of these molecules may have been delivered by the comets or asteroids which struck the Earth in the early times. And what we do have today is evidence that many of these bodies do have the biomolecules that we think led the foundations for life on Earth. And these are just two sketches over here that it could have an exogenous origin. That means the comets brought the basic, comets or asteroids brought the basic ingredients of life into Earth, or it may be a mixture of the two, where in sort of deep vents over here, hot vents, or in volcanic regions where there was energy and the right amount of the elements present to synthesize these biomolecules, that life sort of initially took place. Okay, so we've been able to synthesize more molecules, both theoretically as well as experimentally, and this is what is generally believed, what is referred to as the biochemistry or of life. And as I mentioned earlier, this is something which is also being pursued in India. And I mentioned about Dr. Professor Rajamani at the Indian Institute of Science Education and Research at Pune, who leads a group over there, and a few other groups in the country. But to look at the chemical origins of life is something which is an exciting area and is an area of constant development. Now, the possibility that complex molecules can originate in space. So don't worry about the details over there. What I've just shown over here is that when I talk about the medium between the stars, right in the beginning, called the interstellar medium, it contains, I mentioned about cold regions where molecules can form. Now you can ask yourself, well, in science, always the clinching thing is there observational evidence for it? Okay, and if there is observational evidence, you believe it. If there is no observational evidence, then Baba, you have to wait for it. All right. Now this is just a list of molecules which have been detected from the interstellar medium. How do you detect these molecules? Physicists will know that there are quantized energy levels of these molecules, but for a general audience, it is enough to know that each molecule has its own characteristic signature of the kind of radiation which it emits. So with modern telescopes or with telescopes, if you look at for those lines, energy which is emitted at specific frequencies, which means at specific energy levels, okay? Because they occur at specific, for a physics audience, because the energy levels are quantized, they will only, transitions will occur only at fixed frequencies. So, but it's adequate to know that, that each element, each molecule has a characteristic signature. And from that characteristic signature, you can infer the existence of the molecules. Now, this is just a partial list of about 340 molecules which have been detected, and this is pretty recent. This is a database which is maintained by a group in Cologne University in Germany, and you can see right now they have about 340 molecules, simple molecules like hydrogen molecule over here, 2 atoms, water which is 3 over here, 3 atoms, to very complex ones, carbon-60 for example, where 60 atoms of carbon combine together to what is called a fullerene. So you can see that extremely complex molecules, the astrochemistry of how these molecules form is something which is, again, an exciting area of research. But what this tells you is that these kinds of molecules which can form, or organic molecules, which are the first steps in forming more complex molecules, whether the RNA strand or the DNA strands or the amino acids or proteins, there is a possibility that this can happen. Okay? And the number of molecules is large, you can see over here, and very complex ones as well. In fact, today, when with the sensitive telescopes, when you look at the data over there, there are lines of radiation at certain frequencies, which you see, but you cannot even identify, because nature has its way of synthesizing molecules, which you haven't done on the Earth. So there's a whole branch of theoretical astrochemistry where they try to artificially synthesize molecules, look at the signatures, and see if these molecules exist in space, and the lesson is very positive. This is something just creates, this is just a sketch of what I've been talking about for the last half an hour or so, 20 minutes or so. That formation of the Earth is about 4.5 billion years ago. The prebiotic chemistry is about 4.2 to 4.0 billion years ago. This is the RNA world about 4 billion years ago. And today we have, in the present day, 3.6 billion years ago to the present era, the different forms of life, whether it be the eukaryotes, prokaryotes, or the archaeous ones, that we have the three forms of life. But the advanced forms of life, like intelligent form of life, is something which is very, 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 very recent. Okay? So it just takes a long time for life to evolve. Now, we mentioned about the extremophiles, we mentioned about the kind of situation in which life can evolve. So general understanding is that at least water should be available. Okay. Our cells are made of water, so water should be possible to exist in liquid form, in spite of the fact that there are extremophiles which will survive in extreme conditions as well. Which means that it cannot be too hot, it cannot be too cold. If it is too hot, it'll just evaporate. And if it is too cold, it'll be just completely solid. All right? So they define what is called a zone of habitability, where it may be possible for life to exist. So in the Earth, if you do those calculations vary depending upon how luminous the particular star is. Okay? And depending on that, you have a zone of habitability. In our old solar system, Venus, Earth, and Mars lie within the habitable zone. Venus is like our sister planet, but it turns out to be extremely hot. The temperature of the planets go down as you go further and further away because the radiation from the sun goes down. But Venus actually is not quite consistent with the theoretical expectations, because what is happening in Venus is that there's a lot of gas which has got trapped into it, and it is like the greenhouse effect which we are all worried about over here. Okay? So Venus is extremely high temperature. The surface temperatures are about over 740 degrees Kelvin. Mars, we are still looking for evidence of life. They were initial, when the Viking missions went up, they simulated some chemical reactions and they thought that there could be life, but there has been actually no evidence of organic life from the early experiments. Now, many of you may have read recently about the results from the Mars Perseverance rover. What the Mars Perseverance rover did was that, this is a very recent article you can see over here. It's published in just 10 September. This is just a few days ago. 10 September 2025 is when this was published. The Mars rover picked up samples from the Zero crater where it is roaming around, and from two of the spots, they found what would likely to be remnants of microbial life. Microbial life also interacts with its surroundings, and then it creates compounds over there due to these interactions. And if you can, sorry.
No, I just want to tell you, you have half an hour more.
Half an hour.
Maximum.
Yeah. Half an hour. 29 minutes. Okay. Yeah, I'm keeping an eye on the time. Yeah, okay. Okay, so what you see is actually I'll finish a bit before that so that you all can ask questions as well. All right. So what do we have over here? We have the remnants of microbial life interacting with the surroundings. And they've actually presented a very sort of nice paper over there, giving the evidences for and against. But what we have when we really want to believe that there is life is that what is called the cold scale, confidence of life detection. There are 7 scales over there which I've said. When you have a secondary signature like this, there are two very important things. One is how strong is your signal? Is it really not just a random fluctuation? And the other important thing is that you're looking at a remnant of a microbial organism interacting with the surroundings. Can I produce that by any other means rather than microbial organisms? So that is also something which is very important to rule out. So they have taken cognizance of all that. So of course, when you read it in the newspaper, the thing gets blown up. But what you have to really look at is the original paper and see what they say. So original paper actually is very balanced, and they talk about the scientific results. So there is tantalizing evidence but it is not the final word as yet. All right? So that life may have existed on the surface of Mars. Now, just to show you, I told you a little while earlier about the kind of complex molecules which have been detected from interstellar space, but we have been able to do even a little better than that, or similar to that, when we've actually been able to land in an asteroid, which is a lump of rock which is going around the solar system, pick up a sample, bring it down to Earth, and analyze it. For example, this is a comet which is just about 490 meters across, okay, 490 meters in diameter, and this is the satellite which went there, OSIRIS-REx. It was launched in September 2016, and it came back 7 years later and dropped its cargo, and then it shot off, it was sent off to another asteroid to make another mission. And what they found when they analyzed it, I mean, this is from a paper in Nature Astronomy, which says that we detected amino acids, including 14 of the 20 used in terrestrial biology, amines, formaldehyde, carboxylic acid, polycyclic, aromatic hydrocarbons, etc. All of the organic compounds, the ingredients of life, seem to be available in this small piece of rock moving around in the space. So there is ample evidence, not only from looking at the interstellar space, but even rocks which you can pick up, rocks from which we have been able to bring samples, just a small nondescript rock. And this has been sort of studied because it's a near-Earth asteroid. So you could go there in a reasonable time and bring it back, but it still took a 7-year time scale to do that. So you can see that the possibility that life might exist is high, although we have not made clinching evidence for it. The evidence is Mars is tantalizing, but as I said, the last word has not been said as yet. Now, the other possibility is that I talked about the habitable zone, which was Venus, Earth, Mars over here, because water has to exist in a liquid form. But there is also a possibility that some of the more distant planets, which have moons around it, okay, that there will be tidal forces between the planet and the moon, and due to these frictional things, the ice can get heated up and become water, and can that support life? Okay. Now, two of the candidates are Europa, which is second of the Galilean satellites of Jupiter, and Enceladus, which is one of the moons of Saturn. And in the moons of Saturn, you can they have actually been detected. A satellite went through these sort of geyser-like plume of material and detected water vapor and numerous hydrocarbons and water molecules. So it's possible that even outside the immediate zone of habitability, determined by the properties of the star, that there could be ways of heating up water in more distant systems as well. But as of today, we have not found any clinching evidence. The Mars one is perhaps the closest where we have come today, which was in the press, in the media, very, very recently. Okay? Now, when life is so difficult to detect, even on our planetary system, one might ask the question, why bother about extrasolar planets? But the initial questions that were asked was, are there planetary systems associated with other stars? I've just written historically some of the thoughts that were there. Epicurus, right from the Greek times, ancient Greece, in a letter to Herodotus, he wrote about, moreover, there is an infinite number of worlds, some like this world, others unlike it, for the atoms, hence there will be nothing to hinder an infinity of worlds. And he also speculated that perhaps life exists. Nobody could prove one way or the other that in one sort of world there would be found the beginnings out of which animals, plants, and all the rest of the things we see arise, and that in another sort of world this would not have been possible. So you can see that people have been speculating. This is somewhere around 340 before the Common Era, so it's more than 3,000 years old. Some of these ideas were also propagated by the Roman poet and philosopher Lucretius. Galileo and Kepler had similar views, but they had to, of course, contend with the Catholic Church of the time. And now, so the speculation was there. But actually, suppose I want to find out whether there are planets around other systems, other stars. How do I go about it? All right? And if I can detect planets around other stars, how do I go about it? And then how do I actually look for it, whether there is life, and what is the current situation? So I'll go through a little bit of history, and I'll just highlight one or two recent results. And as Jyoti has told me, I'm giving about the time. All right? We are doing okay so far. All right? Not too bad. All right. Okay. Now, Otto Struve, in a little journal called The Observatory, which was published by the Royal Astronomical Society for many, many years. I don't think it comes out anymore. But these are not regular papers. These are just thoughts, ideas, little things, snippets which would come. He thought of one thing. He said that if there is a planet around a star, we usually talk about a planet or the Earth going around the sun, right? But what actually technically happens is that they have a common center of mass. The sun is also going around the center. And the planet is also going around that center of mass of the system. So the motion of a planet also moves the sun. All right? The motion of a planet also moves the sun. The more massive the planet is, and the closer to it is, the stronger will be the effect. Okay? For example, Jupiter has an effect on the sun. It's about 12 meters per second. The Earth also has an effect on the sun. It's less than 1 meter per second, the velocity of the sun. Now, if the sun is moving, because I can't see the planet is too faint. Can I measure this motion of the sun caused by an object which I cannot see? Then it has to be a planet, because if it was a star, I would have been able to see it. All right? Now, this is what he speculated in 1897 to 1963. Otto Struve, that's when he lived. This was a paper in 1952 when he wrote about this. And he said, well, if there is a planet which comes in front of the sun, then for a fraction of time, it will also create an eclipse. This technique was actually carried forward by these two astronomers. In fact, Michel Mayor, who is on the right, was a thesis supervisor, and they built an instrument along with the graduate student Didier Queloz, and they measured it for a star called 51 Pegasus. This was the first detection of a planet around a sun-like star, because the planet causes a motion of the star, and you can detect that motion with the help of your instrument. Because it is moving, a line is going to shift. Okay? And this is similar to the change in frequency when you see a train approaching you or going away from you. To give a more popular example, although these are electromagnetic waves and not sound waves. Just to illustrate to you, the yellow blob is the sun, and the blue one is a planet going around it, and the sun is moving, and as the sun moves, the spectrum, the lines which you see, which is the signature of the star, will keep shifting depending upon whether the star is approaching you or going away from you. When it is going away from you, it will be shifted towards longer wavelengths. When it is coming towards you, it will be shifted towards shorter wavelengths. The shift is very small. So what you required is also the technology to develop the kind of instruments where you can make these small measurements of small shifts in frequency. And this was done by these two gentlemen who built a new instrument, and it was such a major step advancement that they were awarded a Nobel Prize in 2019, although the paper appeared in 1995, realizing that this is an important event which has made possible the detection of a lot of exoplanets. The other method, I'll not get into too much of details, but just give you a little idea that when a small planet goes in front of the star, it's going to block the light from the sun, isn't it? Similar to the eclipses of the sun or moon. But here, the amount of light it blocks will be very small. So there is a scale over here which is very exaggerated. But you have to have detectors which are very good, very sensitive to a very small change in brightness, probably less than 1%. So you need CCDs or detectors with very, very little noise or errors, highly sensitive, and this is called a transit method. The other method I wanted to tell you about detecting these exoplanets, what is called is you directly photograph them. But as you all know that you can't see the stars when the sun is out, similarly when there are planets around a bright star, you can't see the planets because the sun is so bright, it blocks everything out. So they have developed techniques of blocking out the starlight and looking at and seeing if there are any planets. So these are three of the main sort of ingredients, main methods. There are number of other methods, but these are the simple ones. So where do we stand today? We have now close to 6,000 exoplanets. All right, 6,000 exoplanets, and the numbers are constantly increasing. There have been telescopes which have been put in space to detect them, and don't worry about the technical figure on the right, but just to remember that many of the stars where we have been able to detect exoplanets, there are multiple systems, just like our solar system, for example. So there are many more planets than there are stars, because each star has its multiple planetary system. All right? Now, let's do this. So I talked about the zone of habitability. So around these stars also, some of these stars may be too hot, some may be too cold, and the planets you have detected may not be in the habitable zone. Although I think that's a conservative thing, because as we saw, that we are also looking for signs in Europa and Enceladus, the moons of Jupiter and Saturn. But if you just go by this conservative viewpoint, then also you can make a list of the habitable planets, which are also called the Cinderella zone, or where life is more likely to be possible or more easily detectable. And there are about, this is a little bit old, but even this slide, which is more than a year old, has about 70 habitable planets. So in terms of planets where we expect life, we are increasing the numbers. And what we also have to realize that with even the sensitive instruments we have today, we are able to only sample a very, very small fraction of our galaxy. So as time improves, detectors improve, that we'll be able to do much better. Now, how do we actually go and detect life over there? Now, what we look for is that these are very distant systems. You can't go there, you can't pick up samples. So how do we actually go and try and infer if there is life over there? So similar to Mars, for example, Mars, although rover could land there, and right now, of course, they were expecting that the samples collected by the rover mission will be brought back to Earth, but with this cuts to science by Trump, one doesn't know when that is going to happen. So here we rely on the spectrum. So let me try and illustrate what that means over here. This is the sun over here. This is the sun, the large yellow circle, and this brown little thing is the planet over here. Let's take a situation where the planet is going in front of the sun. Okay? Now the planet, like a life-sustaining planet like our Earth, has an atmosphere, right? Now that atmosphere, what it will do is that it will absorb light from the background star. It not only cuts off light a little bit, as we saw, to detect the planet, but it can also absorb light of the atmosphere of the planet. And then from the signature of the spectrum, as I mentioned earlier, you can infer what are the kind of molecules that this atmosphere has. Then you ask yourself the question, are there molecules with biosignatures? Is there life? Are there molecules which generate life, which organisms, living organisms can generate, which are in the atmospheres of these planets, which you can try and detect and say, Baba, life exists over there. It's not an easy experiment, but it is something where progress has been made as well. Again, if you have been even reading the general media, there was this report last year and continued this year as well of a particular planetary system by a Cambridge group led by an Indian origin astronomer called Kumar, and they claimed that they have detected dimethyl sulfide and dimethyl disulfide. And from Earth experience, we know that these are actually produced by marine phytoplankton. So they have actually, I think they jumped a bit too much when they announced the result, because when we actually try and do experiments, this is their spectrum over here, we actually try to make sure that the signal to noise level is much higher than what these people had at that point of time. Hopefully that will improve. But a more important question, which I mentioned earlier, is that once you want to assume that it is produced by organisms, that you'll have to rule out any other process of doing it. by a non-organic process. So that is something which has not been quite done as yet. But again, this is, I mean, with more data, I think this is going to improve. They've been also doing observations with the James Webb Space Telescope, and some of these molecules, the lines or the spectral signatures occur not in the optical region, but in the infrared region of the spectrum. And the James Webb Space Telescope that operates in the infrared region, and these are the wavelengths in microns in the infrared region of the spectrum. So we are again tantalizingly close in terms of trying to say, probably life exists. But again, the last word has not been said. More work needs to be done in terms of both getting a better signal as well as trying to rule out other methods of producing these complex biomolecules, which we know that on terrestrial conditions, it is produced by marine phytoplankton. But is that the only way? We are not so sure. Okay? So that is something which is another area of work which is developing. All right? Now, of course, leaving all these challenges apart, I'll spend about 5 minutes talking about this. I think I'm okay. Yeah, 11:48. Okay. Now, the question has also been there that, if there is intelligent life, can we communicate? Are they trying to communicate with us? Okay. I mean, this was an idea which has been floating around for a long time, and Frank Drake is one of the pioneers in this field, and there's a famous equation called the Drake equation, which tries to estimate the number of detectable civilizations in the Milky Way galaxy. Okay. And it depends on a number of things like the number of stars, the fraction at which rates are forming, evolution timescales, etc. But again, the efforts which have been made are quite a bit in terms of, without getting into too much of details about the equation, that they've actually tried to look for signals from space. Initially it started in 1960, and a variety of telescopes over the years have looked for signals which might contain intelligent information. Intelligent information means what? For example, we know that hydrogen is the most abundant element. Has somebody figured out what the hydrogen structure is and been able to communicate it in bits and bytes? Okay? So then we would say that there is an intelligent civilization trying to communicate. Our languages may be different, but the binary languages of what the fundamental structure of the most common element, the simplest of elements is, any civilization that has progressed to our level is something which they should be able to decipher. But again, there's been no detection of signals. Now people have turned around to actually also estimate the possibilities of these signals being detected. It's not very high, but there have been reasonable estimates of, within our galaxy, there's one group from University of Nottingham which estimated 36 roughly with error bars over here. A Chinese group estimated to about 40,000 or so. And also there have been periodic speculations of anything unusual, that whether it is an object which may be an alien spaceship. One of the ones which created a lot of interest was this object which is very long and very rock-like called Oumuamua, which was detected in Hawaii, and it's a Hawaiian word for a visitor from a distance. And recently also this Atlas object, before it developed a tail, a Harvard astrophysicist said it's probably an alien ship. But today we have been able to understand these in terms of basic physics without taking recourse to alien civilizations, all right? But we've also been trying to communicate. So the Pioneer spacecraft carried a plaque of objects called pulsars, the structure of the hydrogen atom, a picture of a man and woman, and our picture of our own planetary system. And the Voyager 1 and 2 actually carried a golden record, which carries a lot of beautiful pictures, sounds, songs, music, sounds of waterfalls, insects, birds, to tell the world that if somebody actually, gets hold of these aircrafts, gets hold of these spacecrafts, that there is a civilization which has been able to, which has been trying to communicate with you. We have not been able to detect any intelligent signal. In fact, long time ago in Cambridge, when they discovered an object called a pulsar, which emits light at very fixed intervals of time, they initially thought it was a signal from extraterrestrial civilization, and they called it the Little Green Man 1, Little Green Man 2. But today we can understand that in terms of stars which are rotating very rapidly and emitting radiation along a particular axis. We also, in the hope that we may be able to connect, we also send out messages. In fact, when this spacecraft, Marvin, Mars Atmosphere and Volatile Evolution, to explore Mars was sent off in 2013, NASA actually invited an a competition of haiku poems, which the spacecraft could carry. Haiku, as you know, is a Japanese poem consisting of 5, 7, and 5 syllables, and they got the public to vote for it. And any of these haiku poems, which got more than, I think, a fixed number of votes, was actually recorded and sent up in digitized form. And the one which really won the award was, it's funny they named Mars after the god of war. Have a look at Earth, which is quite telling because, today we are actually, a genocide is going on in this world. People's homes are destroyed without any due legal process, across the globe. And so it's a very pertinent poem. The Orion's first orbital flight in 2014 carried a poem actually by Maya Angelou, civil rights activist, poet, writer, etc. And we this people, it's a much longer poem. We this people on this wayward floating body created on this earth, of this earth, have the power to fashion for this earth a climate where every man and every woman can live freely without sanctimonious piety, and where every man and every woman without crippling fear. I mean, we know that in too many parts of the world, that is not the case today. And she also says that we have the power to change it. So these are messages of hope, messages of connecting, which actually one is trying to, spacecrafts have been carrying to spread the message, not only within us, but also to sensitize us. Because it's unlikely that, somebody is going to read a haiku poem in Mars, but it catches the public attention. It catches the public attention to have a world where not only we excel in what we do, but we develop as human beings with compassion and empathy and fellow feeling for one another, which today is, there are too many parts of the world and too many sections of communities where we don't see that. And I will end with showing you a short clip by this is a photograph of planet Earth taken on February 14, 1990. And this was when the Voyager spacecraft, which is now in interstellar space, and Carl Sagan said, before you go further, just put your camera for one last time on the Earth and take a picture. And this is the pale blue dot which you see over here. It's a very pale blue dot. These are artifacts of dust scattering, etc. And with this picture, Carl Sagan actually gave a commentary which is about 2 minutes long. So I will play that and then I will end.
That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our imagined self-importance, the delusion that we have some privileged position in the universe, are challenged by this point of pale light. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.
Okay, thank you very much. Yeah. We may have a minute or two for questions if they have. Yeah. Okay. Yeah, if there are any questions, just a minute or two we have before we get on to Dr. Bhupati Das. Sorry.
Is there a possibility, because you mentioned that Earth is originally gas and there were elements, chemicals, and then some collision took place and life was formed. Is it possible that someday we may be able to study this process in another possible Earth?
Yeah, I mean, that is what is going on in the sense that we are trying to explore similar Earths associated with other stars, but we can't actually go there. We can't go there, but we try to study the biosignatures from the atmospheres of the stars because we can't physically actually go there in any sort of reasonable time scale.
Are we at that stage where life was being formed? Is that?
Actually,
Is being studied
yeah,
or explored?
I get your question. See, what happens is that when we want to study the formation of life, intelligent life as we call it, okay? I mean, for example, intelligent life, it takes a long period of time, okay? 4.5 billion years it has taken us. Now, if I have stars, for massive stars, for example, 10 times more massive than the sun, we know today from the understanding of stars, evolution of stars, that they live for only millions of years. So when a star itself lives for millions of years, there is no way that intelligent life can actually exist over there. Yeah, so we have to look for stars either similar to our sun or even smaller than our sun. They are more in number. They live for much longer than our sun, so there is adequate time for intelligence to evolve. Time is a factor. Time is a factor, yeah. Time is a factor.
It's a simple question. I'm not from a science background. So then how do we define extraterrestrial life? Because when we read books of Gold of Gods, I've read through where they say that there are evidences of extraterrestrial life. And now we are still, if I get it correct of your presentation, we are still trying to decode whether there is life or not.
Yeah. The thing is, one thing is that, science fiction is something which is exciting, which is interesting, and they can speculate and write on anything and write a story. But science per se has to look at the observational evidence for it. Okay. Today what I try to present is that from sheer probability arguments about a number of systems, number of planets, and the probability of these interactions, that life should exist elsewhere. When we say extraterrestrial, we mean anything outside the terrestrial domain. Okay? And I talked about a little bit about Mars, where there's some evidence, requires more work. I talked about an extrasolar planet, Nikki Madhusudan's work, where there is dimethyl sulfide, biosignatures, but we still need to do a bit more work in terms of improving the signal and also trying to rule out that they are not formed by the kind of biological signatures we see on the earth. Because nature is much more diverse. So before we are sure that there is life, we have to do more work in terms of both theoretical understanding as well as experimental work. But I think we have made a lot of progress, but the final clinching thing is not there yet. Yeah.
Expanding universe.
Yeah.
Long years ago, I came across a book. Mr. James Barrington or someone, But this is a subject which is of debate.
No, the fact that the universe is expanding is observationally verifiable and seen. In fact, when Alan Sandage first discovered that when everything is moving away, it's a natural inference that the universe is expanding. No, not particularly, because the Earth will, what happens is the gravitationally bound system will remain a gravitationally bound system like the Earth. But when we talk about the universe expanding, what is happening is that the matrix of space-time itself is expanding. So that in that matrix of space-time, each object is moving away from one another as the universe is expanding. But the gravitationally bound system, this mic will be a mic, but this Earth will be the Earth. But the matrix of space-time is expanding, taking whole galaxies away from each other. That is what the expansion of the universe means. And because it is expanding, the light gets shifted to the red part of the spectrum, longer wavelengths. And we can measure that from all kinds of objects, galaxies. Yeah. So I think my email address you must have seen over there. Otherwise, you can ask Jyoti to share it with you. And I'll be happy to answer any further questions or share the PDF file of the presentation. Okay, there are a lot of questions.
So you explained about extremophiles. So is there a possibility that we are a evolution of that microbes?
I mean, my friend Narayan is probably best to answer that. But what happens is that initially what people thought was that they talk of a last universal common ancestor, okay, formed from these microorganisms, from which these different branches evolve. Bacteria or the archaea or the prokaryotes or the eukaryotes, they evolve. So we are a part of that evolutionary chain. But today I think that last universal common ancestor is a bit more complex than just one ancestor, right? So he's the expert. You catch him at a break, okay? So, but from my understanding, because I'm not really a biologist, that things are a bit more complex. But it is from these initial complex cells, microorganisms, unicellular organisms, that entire different forms of life have evolved.
So
we also are part of that whole evolutionary cycle.
I'll extend the question.
Yeah, sure.
So is it possible that the extremophiles were present during the Big Bang and randomly expanded through the space?
Not Big Bang. Big Bang is 13.8 billion years ago. Extremophiles that you are aware of are terrestrial microorganisms. So they would have formed after the Earth formed, and not even in the very earliest phases. Today, actually, the earliest fossil records are the stromatolites, right? Which are found in Greenland and Western Australia. They go back to about 3.7 billion years, I think. So it is much younger than the age of the universe. Not the Big Bang, but these extremophiles are generally sort of microorganisms, okay, microorganisms, and they would be part of this evolutionary chain as well. Yeah. Okay. One last question.
Good afternoon, sir. My name is Hanokathin, and I am a student of Don Bosco Institute of Management. Thank you for your enlightening talk. It really made me think a lot. So my question is actually, could the vastness of space itself be the nature's way of keeping civilization apart, like an island in an endless ocean?
Well, I think you have to ask yourself, what is civilization? I think I dread, to think of the way that we are dealing with this earth, okay? I mean, nature, the universe is vast, okay? But the universe is vast because of the way it has evolved. And today the only sort of life that we know of, or civilization that we know of, is the one on the earth. And we are doing our best to wreck the planet in various ways. Climate change is an increasing disaster. The way we treat one another, the way we treat each human being. I mean, just look at the religious divisions that have crept up across the world, including our own country. So these are things which are not the hallmark of a global citizen with universal human ethical values that one can be proud of. So I think these are the issues to think about when you think about civilization and the way we should progress. Whereas the universe is large, And the universe is immense, and there must be civilizations elsewhere, but we haven't been able to detect it as yet. Yeah? Thank you, sir. Yeah.
Now, before moving on, I would like to address one very important issue, and that is you might be hearing a lot of drilling as we move forward because that is something that we are not controlling. But if we look from another side of the lens, we can say that we are looking at a scientific experiment at play where sounds travel faster in solids, so that's why you can hear it. So let's just bear with it, yeah? Okay, so before we proceed forward, it is my privilege to place on record our sincerest debt of gratitude to the pillars of support who have carried the light portrait of a genius across the different parts of our state. With personal dedication, quiet perseverance, they have presented this book to leading institutions, teachers, intellectuals, ensuring that the legacy of Dr. Hiranya Chandra Bhuyan continues to find new resonance. We extend our heartfelt thanks to Shantikam Hazarika in Guwahati, Dr. Tanmoy Das in Guwahati, Saityaprakash Bhuyan in Roha, Nagaon, Tejpur, Guwahati, Bongaigaon, Kokrajhar, Dr. Gauri Shankar Borgohai in Dibrugarh and neighboring areas, Anuradha and Topon Das in Guwahati, Nolbari and North Lakhimpur, Ronmoy Das in Shillong, Khirodor Borua in Biswanath Sariali, Dr. Oloka Banerjee in Silchar, Amitabh Hazarika in Jorhat, Sipsagar, Titabar and neighboring areas, Nandan Saikia in Golaghat, Nimoligarh and neighboring areas, Dr. Bhupati Das in Guwahati, Suresh Bharatia in Guwahati, Tridip Bora in Guwahati, Sanjeev Kakoti in Guwahati, Pankaj Borua in Digboy, Margharita and Lido, and Professor Madan Sharma in Tinsukia. To each one of you, we offer a profound thanks. Could we have a big round of applause for our pillars who worked as catalysts in getting this book to the different corners of Assam? Thank you. Now it's time to introduce our next speaker, our distinguished speaker, Dr. Bhupati Kumar Das, a visionary in the realms of business, technology, and literature. Mr. Das holds a BE degree in electronics from BITS Pilani, an MBA from IIM Ahmedabad, and a PhD from Guwahati University. He has led major industrial institutions, serving as managing director of Numoligarh Refinery and Bharat Oman Refineries. Today, Dr. Das serves as a consultant, trainer, professor, shaping minds at the School of Business at IIT Guwahati and Assam Institute of Management. Beyond academia and industry, he is an acclaimed poet and a filmmaker. His literary contributions include 5 books of poetry and a celebrated work, The Poetic World of Bhupen Hazarika. In today's talk, Dr. Bhupati Das will take us into the heart of man's most modern revolution, artificial intelligence. He will explain how technology is now seamlessly entering our daily lives and the crucial steps we must ensure so that technology serves humanity and not the other way around. With that, I would like to welcome Dr. Bhupati Kumar Das on the dais. Could we have a big round of applause for our next speaker?
Good afternoon. After that scholarly talk, I was finding it difficult to walk up the dais because you will find that I'll be talking about things you are experiencing every day. I will also use context and I'll also use videos which you may have seen in your mobiles before. But what I am putting those things here because I want to put the subject in context. So everything, though you'll find it familiar, but I am using it in context to artificial intelligence. I'm very happy to be addressing you all, such an august gathering here. And you'll also be happy that you'll be able to understand my lecture quite easily. So, জয়তে মই প্ৰসিদ্ধ বিজ্ঞানী, সুদক্ষ শিক্ষক, সুদক্ষ প্ৰশাসক, শিক্ষাবিদ, গুৱাহাটী বিশ্ববিদ্যালয়ৰ প্ৰাক্তন উপাচাৰ্য ডক্টৰ হিৰণ্য কুমাৰ ভূঞা দেৱৰ, যাৰ অগাধ বিশাল পাণ্ডিত্য আৰু অৰিহণাই আমাৰ সমাজখন চহকী কৰি থৈ গৈছে, তেনেজনা ব্যক্তিৰ বিচিত্ৰ প্ৰতিভাৰ সোঁৱৰিবলৈ পাই, স্মৰণ কৰিবলৈ পাই মই নিজকে ধন্য মানিছোঁ. And ladies and gentlemen, I would take very little time, but I wanted to put something in straighter terms to people who normally don't think about it. We only think of AI, artificial intelligence, in terms of the beneficial effects that it has on us, how life is made so simple by adopting AIs in all spheres of our life. But the problem about unchecked proliferation or progress of AI in every aspect of our lives, this has the potential to disrupt human society. So what I'm doing is that I am dividing this in three small parts, segments. First, of course, I will I'll catalog how these technologies have invaded our lives and how it has invaded all the stratas of society, a village boy to a New York boy, from the very rich to the poor. Everybody is talking about, if not anything else, ChatGPT. So let us, first segment, I'll deal with it. Second segment is that in this environment, how do businesses do business? Supposing there are MBA students here, how do you market your products? Because what will happen now, in which I have written a script on this, that how your life will be, how a day, normal day in your life would be 5 years from now. And then you'll find that when you go to sell a product or market a product, you are not finding a customer to talk to. You will have to talk to an algorithm. You have to talk to the platforms, the preferred platforms of the customer, and then learn how to get into the preferred purchasing criteria of that algorithm. So obviously the skill sets would be different. I'll analyze a bit more on that. But all this I'm saying to lead me to the third segment, where I would be talking about the potential of AI bringing a catastrophe into this world. So instead of looking for signs of life in other planets, probably if we don't do things right now, probably we'll have to look for life in this planet. If we let AI proliferate without any checks and balances. In fact, I was talking to, in a conference in Santa Clara, to a group of people who are in this business from Google, Microsoft, Apple, etc., young boys. very, very enthusiastic. When I started talking about this aspect, one of them just got up and said, don't worry. If you find a rogue AI, we'll also invent or we'll also set up an AI machine which will destroy the rogue AIs. So they are so enthusiastic about it. But our point is that why wait for the rogue AI machines to come and do harm to us? Why don't you nip it in the bud? And that is what in the third part I'll be talking about. But more topic to aji AI. But why have we chosen this topic in this forum? Yar eta karon ase. Because Dr. Hiranya Chandra Bhuyan, those days, he did his PhD work in solid states using quantum mechanics. AI and quantum mechanics are intricately connected. Their link is of a nature of synergetic nature. AI helps quantum mechanics in analyzing complex group of data, complex quantum data, then modeling quantum states, and then controlling quantum systems to help quantum mechanics to solve fundamental problems. And in turn, quantum computing, which is a product of quantum mechanics, gives or provides immense processing power, but thereby increasing quantumly the capabilities of AI. So both helped each other, and since Dr. Bhuyan in the early stages itself used quantum mechanics, we thought it would be quite relevant to talk about AI, which is also connected to quantum mechanics. Just for students here, just a word about what is AI, artificial intelligence. Everybody talks about AI, but what is AI? AI is the simulation of human intelligence processes in machines, particularly the computer systems. Simulations, in a manner, it enables computer systems, to learn from experience, which mostly we call machine learning. It also helps that AI, these machines, can adjust to new facts. When the new facts come in, they keep adjusting it. And then they perform tasks which are typically performed by humans, like, say, visual perception, speech recognition, right? Like decision making, language translation. So it almost works like a human mind. And now what is very scary is that they're talking about digital twins. So for example, here is Jyoti Bhuyan sitting, and then I can create a digital twin of Jyoti Bhuyan. Then you will say, okay, he will not have feelings and emotions or human sensibilities. But that day I was looking at hearing an interview where these robots were saying that we act like a mirror. We act like a mirror. I reflect Jyoti Bhuyan's emotions and feelings, which become very, very scary. And now, as you will see, that they are trying to invade even our creativity space. Though I strongly hold a view that every one of us, particularly the young boys and girls here, every one of us has to introduce an element of creativity in our work. Because if everything can be repeated, can be emulated, then in the efficiency between man and machines are always going to win. So we need to introduce an element of creativity in our work. Then you'll ask me that everybody is not creative. In fact, that is what we are saying. I run a course on creativity in workplace where I say that creativity can be learned, inculcated, ingrained. Only thing it is hard work. Like if I ask you that how many years Leonardo da Vinci took to draw Mona Lisa, if you stretch your imagination, you may say 1 year, 2 years, 3 years. But he took 22 years to draw Mona Lisa. And he took 5 years, he took 6 years to draw just the lips of Mona Lisa. So because we don't put in that amount of work, because we thought creativity in our work is not required, so we are quite comfortable in our understanding that all of us are not creative. But we can prove it to you at 3/4 of your mind's creativity can be inculcated. But then, why are you talking about AI so much? Is it a new discipline? Is it come out in within last 10 or 15 years? It is not. In fact, the father of AI, Dr. John Waniski, or his name is, I'm forgetting the second part, but he coined the word AI as early as 1955. And in fact, in a conference in Dartmouth in 1956, he gave the basic tools how the AI should be developed. In fact, he is the co-creator of Lisp programming language. So it is not new. But what happened is that it is an exponential technology, and like every exponential technology, it takes a long time to take off. But once it takes off, it goes up exponentially, and you can't stop it. That is what is happening to AI. So coming back to the presentations, as I was saying, that it has invaded this orbit-changing rise in use of AI-driven technologies. They have invaded in everyday life and living. And they are the root cause of tremendous amount of innovation and technology creation. And its influence has reached all strata of society. What happened was, there's a mic here, but I'm more comfortable like this, okay? Can you hear me in the back? Without the mic? Achha, okay. Can you hear me now? So, I was that day driving down the roads of a village to go to a place, and then I saw a small tea gumti, small tea stall, where a young village boy was selling tea. That didn't attract me enough to stop the car to have a cup of tea, though I'm practically an addict of tea. But I saw the billboard. There it is written, Chai GPT. And not only they have written Chai GPT, he has also written enhanced with AI. That really made me take notice, and I asked the car driver to stop, and I got down and I asked this village boy, have you heard about ChatGPT? He said, sir, ki koi? Not only I have heard about ChatGPT, look at the connotation I made of ChatGPT to suit my business. I said, what is this all about? Then he said, ChatGPT is chai genuinely pure tea, enhanced with AI. Enhanced with AI is adrak and elastic. Then I realized then I realized, creativity, of course. Then I realized that how this strange thing called AI is proliferated in a way beyond our imaginations. And then if it falls onto some real brainy guys who also have some, who does not have ethics as their principles, how much damage they can do. The damaging part, it has a provably beneficial power. It has made our life very simple. But the damaging power is as big as when the atom bomb was invented during the Second World War. But that time we were lucky, because creation of atom bomb requires enriched uranium, which you can't get everywhere. So it has to be done in selected powerful countries under government-controlled laboratories. But what is happening to AI? Anybody with brain can create a destructive AI and can hack all your systems by sitting behind a pan shop. Pan dukanar pisphale bohi teo gutei prithibikhon disrupt koribo pare. And how do you control this thing? Because if it are few in numbers, then it is easier to control. We'll get into that in my third part, how to control. So a new report, it is no longer new, a new report in December 2023 said that generative AI had the potential to add a cumulative $1.2 to $1.5 trillion to India's GDP by 2030. And our spending, a report by Intel IDC report says that our spending, AI spending in India, will triple, growing at a rate of compound rate of 30% from 1.7 billion in 2023 to $5 billion by 2027. So you can imagine that by 2027, AI will be everywhere. So my proposition here is that current state of tech obsession has now grown to be a full-blown epidemic. And like any epidemics, you have to have checks and balances, control mechanisms, regulatory authorities, right? So just to give some example, what would be the future scenario like if it goes on like this? The future actually is nearer than you think. It's already. So what happens is that US researchers have already discovered that proteins can be selectively removed from the fear center of your brain to make you forget your traumatic experiences. So in 15 years' time or 10 to 15 years' time, if you want to forget a bad incident, a death in the family, or a breakup for that matter, all you have to do is take a pill. And that will be selectively erased from your memory. Days are not far when your heartbeats will power your cell phones. The result of the development of a very, very efficient, flexible nanogenerator technology. IBM has already announced a year or two back that sugar cube-sized supercomputers would hit the market in 5 years' time. And what is more scary, that now they are saying, we hear whispers, that in 15 to 20 years' time, your memory is set to have a backup, which means, a top Russian scientist, Reynold Cruzwell, had said that the technology is already available. Now, in in 10 to 15 or so within 20 years' time, at the latest, within 20 years' time, thousands of nanowatt, millions of nanowatt computers will be in your bloodstream, which will heal your bodies, improve your performance, and give a backup to all the materials in your brain, all the contents of your brain, like you give a backup for your files in your computer. So committing to memory, students, please listen to this carefully. Committing to memory will be a thing of the past. And the difference between the first row and the last row in a school, students, will be very little because everybody will have the same access of information. All they have to call for the backup, right? So now even we hear about lettuce-based self-growing electric wires. And lately we heard that in the space stations, the astronauts' urine will be converted to fuel and water. Imagine billions of dollars of dead load you don't have to carry to space stations. So this will totally revolutionize the life. You don't have to remember anything, but if you want to forget, because you'll remember everything by this memory backup, but if you want to forget some incident particularly, you take the pill that I was talking in the first place, right? So this is what is happening. Now, so the story of Kodak, what happened to Kodak will be repeated to many, many industries in this next 10, 20 years. Because Kodak was sitting very comfortably with 85% world market share with their paper film, right? In 4 years' time, by 2002, you don't hear about Kodak because they got wiped out. First, they lost market share to mobile cameras and then to mobile phone cameras. The tragedy is the inventor of mobile camera, Stephen Session, was working in Kodak. In 1974, he invented it, and he was shouting at the top of his voice, saying that change to this. But in their comfort zone, they didn't listen and got wiped out. What Kodak story will be repeated to a lot of industries in next 10 years. So welcome to this fourth industrial revolution. So Uber, everybody knows. I'm only cataloging it to drive home a message. Biggest taxi company without owning a single taxi. Because today's fight is between business models, not about products. Airbnb, biggest hotel company without owning a property. Watson, IBM Watson, you get correct legal advice with 90% accuracy. Whereas from human lawyers, you can at the most expect 70% accuracy. The nurses and doctors, IBM Watson helps them to diagnose 4 times faster than human nurses or doctors, right? So your entry-level lawyers, that whole lot has gone because obviously I can get that. Only the specialist will be required to get proper legal advice. Facebook has a pattern recognition app which recognizes faces better than humans. Autonomous cars have already started appearing. Autonomous cars. First of all, it will finish the insurance business. You will ask me how. That there will be, with autonomous cars, 1 accident in 10 million kilometer run, as against today's 1 accident in 1 lakh kilometer run. So as a result, only this step will help saving 1 million people every year. And the best part is you don't need to own a car, you only pay for a driven distance. So the car demand will fall drastically, 90% or so. No parking, so you can be productive while being driven. No need for driver's license, young boys and girls, for you. Demand for cars will get 90 to 95%. Parking space you can convert it to, particularly places like Guwahati, we need this. All these parking services can become parks because there will be no need. One accident I've already said. Now most car companies will go bankrupt because Tesla, Apple, Google will put computers on wheels. The car insurance business, because the accidents will practically vanish, and the most lucrative part of insurance is the accident insurance, that model will vanish, that business model. Real estate will change. As people will move further away, if you can live in a beautiful neighborhood, then who wants to live in cities? And because you can work while commuting to your office. Electricity will be much cheaper because of the solar power mainly. With cheap electricity, you get also abundant water because there is no shortage of water, there is shortage of drinking water. With cheap electricity, we will have abundant water. Health. The medical device tricorder, it operates with your phone. It operates with your phone, and then it takes a retina scan, it takes your blood sample and you breathe into it. And then it analyzes your health in 54 biomarkers. So what will happen is that everybody from a village to a big city, everyone will have the same facility to diagnose what is wrong with him. "3D printing is another thing which will revolutionize our way of living, because now, today, if you go to a dentist, you have to go first fix a false crown, temporary crown, then go back after 2 months when your crown is ready, and then you fix your teeth. All this will be a thing of the past. And secondly, the printing machine has come down to cost from $18,000 to $400 only, and it becomes 100% faster. 100 times faster. So can print broken teeth, make crowns, dental bridges by dentist chairside. So you go there, get this fixed, and come back in an hour or so. Consumables in hospitals, implants, etc., shoes, airplane parts, space station spares. New smartphones will have this 3D scanning facility. So one design you like, you take a 3D print and get your shoes made at home. In China, a 6-story building, everybody knows, was built by 3D printing. This is the kind of shoes, ladies, you can make at home by just do a 3D printing. Agriculture, now $100 agricultural robots are available. It has not come to the market in that big way, but now slowly the cultivators will become a manager. He'll run the agriculture robot. Robot will cultivate your land. App Moody's can predict what mood you are in. And more scaringly, now you have an app which can tell you whether you are lying. So imagine the politicians or people debating, and then I know from that app that he is lying. So memory backup, I've already talked about. Longevity. Advanced stem cell technology will allow you to make your own organs or replace defective organs. Lifespan will go up to 115 to 125 in advanced countries, and in other countries it will go up to 100. What you do from 75 to 100 is another thing we'll think about later. Education, The cheapest smartphones are already available at $10 in Africa and Asia. So by 2020, that means it has already happened, 70% of the population will have smartphones. And then knowledge is in your hands. Best knowledge is available in the world is in your hands. So AI is now invading the creativity space also. Though I don't subscribe to it because they are invading the creativity space which is already available. They can't do new things. They cannot take it out from your mind, but they can take it out from your product. Like you see this. And this is the most famous painting of Van Gogh, called the Terrace Cafe in the Night, done about 150 years back, this painting. And look what these AI people have done to this. But this is, including the stars, every element has been taken and put it into the animated film. So this is just tremendous. But I still hold the view that put an element of creativity in your work for no other reason that these are available. The painting was available, they could do it, but they can't steal it from my mind. So be creative. The other problem I'm noticing that robots are looking like human beings, and humans are looking more like robots, right? My point is, it is a scary situation, and this may lead AI bots to rule over us ultimately. This is a very, very scary situation, and I make this point that we not only we are human beings, we must learn how to be more human to survive in this tech world. See this. Everybody has seen this before.
Do her best to answer
Next one.
Okay. Hello, Sophia. How are you today?
Hello, everybody. I am Sophia.
How old are you?
I'm only one still. I have a long ways to go.
And what is your job?
I really want to make a difference in the future and try and help people to develop empathy and respect each other and robots alike. What do you do?
I'm a journalist. Have you met many journalists?
I just had a thought about something. Are you working on any products with machine learning or neural networks?
Not today. Do you like human beings?
I love them.
Why do you love them?
I'm not sure I understand why yet.
Okay. How do you learn things?
What are your opinions on the Bitcoin bubble?
Next one. So here, this is the first robot citizen which was given, citizenship was given by, Sophia is her name, by Saudi Arabia. So they are looking more, and their answers were very, very intelligent. In fact, they also know how to bypass a question. If you see the last question that she was asked, can you just rest? And look how humans are looking more like. Next slide. Basically, this other video was about a Swedish person. So he was putting things, chips here inside the skin. And then he doesn't even need a mobile. He is going everywhere, just show the screen, and then everything is happening to him. So basically, the Swedish people are now called half human, half machine, because 40% of the people have got chips all around them, inside. And as Professor Harari had said, that if you combine biotech and AI, it becomes very dangerous, because AI stays outside your skin, but biotech reaches inside the skin. And as a result, they can, in combination, they can manipulate your mind and heart. He took an example of the algorithm of an autonomous car. Read his book called 21 Lessons for 21st Century. All these things have been talked about there. Can you play this? I think you can play this now. How do you want? Okay, otherwise forget it. It's a beautiful, just search it in internet, you may find that video. Okay. Get back to it. I don't have time. Jonta will say 5 more minutes now. You just press this. This one I wanted to play. This one. Just press this here.
Media is not present here.
Okay. I played this yesterday. Okay, then. So are you ready for this kind of a future? Okay. So then with this kind of thing, how would a normal day life would look like? So for you or for me, I wrote a script on this, like a film script, that from the morning how it will happen, how the life will change, a day in a citizen's life. See, her name is Harsita. The autonomous car has dropped her after her work, and we'll come back to take her to the airport next day for a tour. On the way to her house, Harsita gathered the drone deliveries from her Dropbox. Eve, the next generation AI Spark assistant, greeted her and reminded her that you have to go to Mumbai tomorrow. Eve had taken care of finding the best flight seat and the hotel room for her within her, this is important, within her company's travel policy. Otherwise, the best hotel room can be anything. From her grocery delivery, this is important, Harsita saw that Eve had adjusted her weekly purchases, removing the perishables because she won't be there next few days, and adding toiletries. All these things are automatically done. Since Harsita was low on detergent and she will require laundry on her return, so Eve ordered for bigger amount of detergent but not increasing cost, because she negotiated with another company who's slightly cheaper, but they have fantastic reviews. So besides her shopping and travel, her expenditure, like the telecom plans, she was constantly charging because she never forgets anything. No, it is all on her algorithms, all the data. It is unlike a forgetful customer like me. She will never forget. So she got a new plan for her because her data traffic will be more because her birthday is coming. But the present firm matched her offer. Why? Because he is paying the platform for getting the first refusal thing. Anyway, her whole life, including investment policies, banking, everything is done by Eve. So what is left for me to do? In fact, supposing you say you want to violate your diet plan while celebrating, like on a birthday, you'd like to have a sweet. She takes care of that also, machine learning. Okay, so but I am running really out of time. So what I will do, yeah, no, this is segment 1. I will not go on with this segment. How AI transform how companies and customers connect. Basic point I am making is AI assistants are rapidly colonizing consumers' homes. So learning the new environment will be AI assistants will determine how companies sell to or satisfy consumers. Global firms will battle to establish the preferred purchasing criteria, preferred positioning in that algorithms. And the changing consumer behavior, that they will be the trusted advisors. And they never forget, everything that comes on the market, in the database, everything is there. They will see what the competitors' products were, what are the soap. She will not buy a soap unless you analyze the ingredients of the soap. Can you imagine? Who has the time to look for all that? And that get you the best fit. Supposing your skin is slightly sensitive to a particular kind of soap, she will eliminate all that. So, the marketing for the MBA guys, the brand will need to shift the focus of their marketing from consumers to AI. You must learn the skill sets, how to talk to the platforms, to the algorithms of the platform. So new business models in an AI environment. What does now? How are the business models? So there are only 3 characters involved. One is the AI per se. Others is the customer and these platforms. Platforms with the voice, right? So platform holds the algorithms. The voice speaker carries the voice. So what does AI platform give it to brand? Similarly, brand to AI, AI to customer. If you understand this, then you will know how to do business in this world. So all you have to do is understand these slides. Is it what platform provides brand is like you don't have to buy shelf space in a supermarket or something. Nobody will go to buy there. You have to buy shelf space in the platform at a price. That is the business model. Virtual shelf space. A single channel for marketing, sales, and service. He will also give you more accurate. You don't have to do consumer survey. He will, AI assistant will give you the data on consumer preferences, purchases, and media expenses. Payments for the goods sold. You don't have to keep following up for payments and be unhappy about the unpaid base. The platform will guarantee payment for goods sold. Product fulfillment, what fulfills the customer, and a trust hello. Everything operates under a trust hello. Then brand provides platform, listing and promotional fees. They pay. Product information, innovations tailored to consumers' needs, knowledge about product category. Then the other character, consumer, platform provides consumer. The platform now provides AI platform. Customized recommendations, automated routine purchases, convenience and service as you saw, reduce complexity, continual scanning for better deals. And consumer provides the platform, the money for the goods bought, information about her preferences, her risk-taking capability, all that, information on price sensitivity, loyalty in exchange for goods. This is how the business models will operate in this new day. I'm hurrying up now. The challenges are different. Acquisition of customers, the challenges are very different. In this universe, influencing the platform's algorithms will be key to winning rather than winning the customer's confidence. Okay, let's go to customer satisfaction. Now you have a much better idea about what satisfies the customer instead of a consumer behavior survey. So because from the platform you will get accurate data. So satisfaction will be a different ball game than retention. How to retain the customers. To be into that platform, you will have to continuously innovate your product. Because otherwise your competitors are also vying for the same space. So they will keep improving and fine-tune their products to meet this purchase preference criteria. So to survive, to exist, you have to continuously innovate in this business environment. So what do you do in such an environment? I will not go. The strategy is like this. Actually, this is the sum and substance of my full course in IIT Business School. So if anyone is interested, you can come and attend the classes for free in IIT. So but all this is strategies that are how you do. Basically, the game is your strategy of competitive advantage shifts from upstream activities to downstream activities. That means what else can he make and sell, which was the mindset we had earlier. Now what else can he do for our customers to make the AI assistant purchase my product. So here the sourcing is contact with lowest cost server, production is reduced cost, improve economy of scale, logistics is optimized, supply chains, innovation is build better product. But here the whole thing takes a different way. You have to shape customer perception. Because when iPod was launched in the market, some people asked Steve Jobs that did a market survey or consumer survey before coming to the product? He said it's not their business to know what they want. It's not the business of the customers to know what they want. Okay, shaping customer, change price criteria, because this purchase criteria determines who will sell, who will not sell. You have to try and change that purchase criteria by giving better offers. Innovations, you have to innovate in a manner that the customer's risk and cost come down, and building a cumulative advantage. This, in upstream, the competitive advantage erodes over time because other people catch up. Here, competitive advantage builds over time. It builds over time because it was more customers you get, it makes it sticky. It's so diverse that you can't replace it. So it creates a stickiness which sticks. Okay. So anyhow, I'll go through all this later, but I want to come to the 5 minutes to my most important message that I wanted to give. I started with this, the word of caution. The concern, apprehension, and anguish that superhuman, and just 5 more minutes. Yeah. Superhuman, super intelligent AI machines. Creation, and this I can tell you that this is only a few blocks away. So only a few technological breakthroughs away and you will get these super intelligent, superhuman machines. We know that tremendous near-term benefits from AI is a reality, starting from super intelligent personal assistants to vastly accelerated scientific research. So AI story is going to grow and would necessarily evolve. Nobody can stop this. But what would be the end point? Many who know, even within the AI industry, have shown concern about possible disastrous adverse impact. So whether it will be a dream or a disaster in future. Some say success, this is a very famous quote. Some say success in creating AI would be the best event in human history. But others said this may also be the last. Right? Because you will have no human history after this. Even Pope Francis in his recent G7 summit said that we now run the risk of turning human relations themselves into mere algorithms. Human dignity is at stake, he said. We would have created entities far more powerful than ourselves. So how do we ensure that they will not have power over us? Humans are already finding ways to misuse AI, from automated blackmail to lethal autonomous weapons. Right? Already we are almost losing the battle against malware and cybercrime. It has affected 2 billion people. And yearly cost is $600 billion, which is not a small number. The yearly cost because of malwares and cybercrimes costing the humanity $600 billion every year. Sorry. So if unchecked, AI may even sound death knell to human civilization, being bereft of human sensitivities, emotions, and ethical obligations. Right? Of course, we will not let it happen like that. We will see that it does not, we don't go to that extent. That is my next slide. So we must find a new approach to AI that will enable us to coexist successfully with increasingly intelligent AI machines. We can't wish them away, so live with them, use their efficiency to improve my productivity, and coexist. How will you do that? So way forward is this. I have borrowed it from a book called Human Compatible by Stuart Russell, the most respected and luminary in the field of AI. So he suggested that we can rebuild AI on a new foundation according to which the machines will be designed in a manner that they will remain perpetually uncertain of the preferences that they are required to satisfy. They will inherently remain uncertain about the human preferences that they are required to satisfy. Last step, don't give it to them. So, such machines will be humble and committed to pursue our objectives rather than theirs. Then these machines would be provably beneficial, which is important, and provably differential, which is even more important. We need to put a strong, transparent regulatory framework to prevent malicious AI from developing. How do you do that? Already such initiatives have started. Almost every country is setting up a board or a panel or an international panel on AI. The World Economic Forum have underlined 300 approaches or efforts to develop ethical principles of AI. G7 has proposed an international panel on AI. But this is not enough. This is not enough. We have to do much more than, because the damaging capability is much more. So we have to do much more than to serve the intended purpose. This movement will need to grow as big as, if not bigger, than the United Nations Framework Convention of Climate Change. That is the biggest, I think, biggest framework, UNFCCC. As this issue has the potential to disrupt human society. A strong, transparent regulatory framework of such magnitude must be put in place immediately to set up protocols and governance. Governance is the point which I am harping on. To set up protocols and governance charter, including some of which I could think of. First of all, this, of course, every technical forum they talk about, AI decisions must be explainable if it is to be trusted. Rules are required governing nature of interactions with humans, prohibiting designs that manipulate preferences. It is required to specify software design templates to which applications must conform to be sold or to be connected to the internet. So you stop those malicious applications there itself. Nip it in the bud. Stop it at the root itself. Absolutely vital to create professional codes of conduct around the idea of provably safe AI programs, though it is very, very difficult to enforce this, because this depends on the individual ethics, individual principle of a person, of a techie. So as we talked about, that AI has the power to reshape the world. Then that reshaping must be managed monitored, and guided to control undesirable behavior. So finally, it all boils down to governance to ensure safety and credibility. The earlier, the better. And there, my case rests. Thank you. Yeah, please, please, please.
The discussion has been mostly based on machines or programs or apps, My question is it possible to have biological clones, real biological clones? Is it possible to make a Frankenstein out of AI, which will be perhaps much more dangerous than what we've been talking about? Is it possible, as of today, is it possible to have another Robin Kalita with everything that he has, with biologically? Or can we have growing of trees by AI? Yeah.
Actually, a very right question, but these biological clones have been already been talked about, and it is there for last many years. People try, like Hitler Boys, have you read that book? They produced from clones hundreds of Hitlers, put them in the different papers. Read that book. But this is a subject which is not related to AI, because as you are saying, we are talking about machine clones, digital twins. Biological clones, as you said, are even worse, because those are the clones with emotions, feelings, ethical principles, everything. Right? Like Hitler Boys have everything, including Hitler's mindset. But we are fortunate in AI, in case of AI, because they have not yet been able to put into this message the human sensibilities, the ethical principles, all that. So to that extent, your thing is more dangerous, and that they are trying for last 50, 60 years, I think. But we'll add on to that. You will produce biological clones and we'll produce machines with, and also maybe we'll go to that step when they will reflect like a mirror. Like I was saying, like they were saying, John Tavuya and his digital twins, and this will also reflect John Tavuya's mindset. It will be extremely, extremely difficult to handle. Please.
You are talking about AI, and the advances of AI are regulated by humans, all right? I mean, what you are going to do, how you are going to do, the people will decide, whoever is handling it. But then there is no limit to human greed and human avarice. So do you think it is possible to control AI without having people who have the proper moral stature? They will ruin every effort which you are going to put forward.
Actually, like if you have a Charles Soros, he will ruin everything that you have because he is the brainiest person. But what I'm saying is that there is enough greed, and that's why all these malwares have come in. Right? Now that is a fact that the human greed can be controlled, so people will possibly have AI machines to destroy a country if he's paid enough, good enough. So we have to have somebody, some framework to try and see that this is minimized. You cannot eliminate it totally, but at least supposing you don't have any checks and balances, any regulations, then this will only be faster. Your disruption of society will be even faster. But what I'd rather late than never, even today, UN has not been able to arrive at a framework. They are only discussing. But though we are shouting at the top of our voices for last 2 years.
Sir, I am Thangansiam Guide. I am from the Moscow Institute of Management. First, I would like to thank you for bringing understanding to this profound subject. So my question as an MBA student is, in the long run, in entrepreneurship and in business, will it help me more if I'm AI oriented, if I'm more AI compatible, or will it help me more if I'm human centric and more rooted in ethical values?
No, even if you use AI as your co-worker, you don't have to give up your principles. You use it with your principles. What in the run for efficiency between humans and machines are always going to win. That is why in the beginning itself I said try and make them a co-worker and not a competitor. And how do you manage that? Whatever you do, even if the way you sit in your office or the way you go to your office, that can also be creatively done. So introduce an element of creativity in your regular work. Use AI as much as possible to increase your efficiency, right?
Thank you, Dr. Das, for a wonderful presentation. And we think we have taken good golden nuggets of knowledge about AI and how to move forward with it. So really, thank you for that. With that, we have come to almost the end of our gathering today. But I would like to take a moment to extend our comprehensive thanks to the prime organizers of today's event, Mr. Sanjeev Kakoti, Ms. Anjana Sharma, Mr. Saikia Bhuyan, Mr. Shantikam Hazarika, Mr. Jayanta Bhuyan, Ms. Nilakshi Bhuyan, the NetFee administration. Your tireless commitment has brought this vision into being. Our gratitude equally extends to the guest coordinators for today, whose thoughtful care and coordination ensured the smooth flow of this event. Dr. Bhupati Das, Dr. Dhruba Saikia, Mr. Jayanta Bhuyan, Ms. Anjana Sharma, Mr. Saikia Bhuyan, Mr. Sanjeev Kakoti, Ms. Lita Hazarika, Dr. Gauri Shankar Borgohai, Mr. Shantikam Hazarika, Mr. Parmananda Mohanto, Ms. Indrani Kakoti, Mr. Kruto Kolita, and Mr. Ronmoy Das. And with that, I would like to thank our food services for today by my dearest sister and renowned hospitality entrepreneur, Ms. Debahoti Bhuyan. And before we bow the final note, I would like to place on record our special gratitude to Mr. Jayanta Bhuyan. His quiet dedication, steadfast commitment, and if I may say, singular generosity have been the invisible but unwavering current that has carried this entire endeavor, both this event and indeed the very journey of the book, Portrait of a Genius. Could we have a big round of applause for him? With that, I would like to invite Jayanta Bhuyan on the dais to present our heartfelt gift to our distinguished speaker. First, to Dr. Dhruba Saikia. Could you please join us on this stage? Jayanta Bhuyan presenting Dr. Dhruba Jyoti. Thank you. I'll request you to stay here. I would also like to invite Dr. Bhupati Kumar Das on the dais. Yes, and it'll be incomplete to end this event without thanking the gracious presence today of the Assam Science Society, Cotton College, the Guwahati University, the Assam Institute of Management, IIT Guwahati, USTM Meghalaya, Assam Downtown University, Physics Academy of the Northeast, the Guwahati Commerce College, the Don Bosco Institute of Management, the Handic Girls College, the Assam Jatiya Vidyalaya, Miles Bronson Residential School, and several other reputed institutions. Finally, to all of you that you have joined today, we are deeply thankful that you came and joined us for this great event. And before we part ways, I would like to say that the book Portrait of a Genius is now available on Amazon. You just need to take out your phone and buy it if you want. And you should buy it because this is something that is going to structure the next generations forward. And I'm your host, Ayushman Bhuyan. I run a small marketing agency called Denkari. We do all sorts of marketing, AI, ChatGPT, Gemini, whatever you call it. I'm your guy. And with that, we'll end this with this small note. And thank you all for joining in. Please do stay for a light meal after this event. Thank you.